This is a stepper motor controller for rotating antennas. Now, as you can see in the display, it shows ME, which stands for memory location. It is one memory. POS stands for position. It is displaying 000 degree, that is, it is at 0 degree position. S stands for the step size. Now it is 5 degree step size. MAN stands for manual mode. It can be shifted to auto mode. F stands for fast. That is, the motor is going to rotate fast. As you can see, the display LED of fast is glowing right now. CW stands for clockwise. So the motor is going to be rotated in clockwise mode. It can be shifted to CCW, that is counterclockwise, so that the motor can be rotated in anti-clockwise direction. This is normally used to find out the reflections due to walls and other objects. As you can see, the motor block, it displays on, that is, whenever the motor is on, while we ask the motor to start rotating, the motor LED will glow and the position LED will be off, indicating that the motor is rotating and it has not reached at desired position. Here, because the motor has reached to the desired position, which is already 0 degrees, so that's why the position LED is glowing. In the trigger output, as you can see, we have not selected auto, so auto LED is not glowing. And trigger out is a pulsed output which is available here and which can be connected to receiver trigger stepper in, so that the pulses at each time motor rotate and reaches to a desired position, reaches to the receiver. For example, if we have selected 5 degree mode, that means the motor is going to rotate 72 times in 5 degree steps, and 72 pulses will be given from this to the receiver, and the receiver memory will advance 72 times, so that 72 memory locations of an antenna at desired positions with their respective field strength or signal level will be available at the receiver using this stepper. As you can see, it has 5 controls: escape, menu, enter, up and down. Now it also consists of a motor which is built inside the instrument, and as you can see, we have a slider here. We will use a Phillips screwdriver provided. As you can see, it has a shaft and it has a D-cut, and because it's a stepper motor, so one should not try to rotate it manually. Now we try to put this screw right on the face of the D-cut. And once it reaches to the bottom level, we will tighten this to the shaft. This is a simple collar. Now as you can see, it has a slider. It has a small cut here and a bigger cut here. This is used to set the antenna to its phase center. Normally different antennas have different phase centers, like horns will have different phase centers. In this case, it's a simple dipole, so it is virtually at the center. So this is a slider which slides and can be used to vary the phase center. Now in this case, we'll keep it at the center. This slider, the system comes in this form, so that one can put a slider here. And tighten this shaft and adjust accordingly. Similarly, these are all non-metallic material used to reduce the RCS and the purity of pattern. There is a cube provided at the top of the non-metallic shaft where any antenna can be connected. As you can see, this is the dipole antenna. It can be connected in azimuth or elevation mode with the help of a screw and screwdriver provided. Now we try to rotate the antenna in auto mode. We shift the manual to auto mode and press enter. Now as you can see, the motor is rotating in automatic mode in every 5-degree steps, and the trigger output is available here. And as you can see, the auto LED is glowing, and as the motor keeps rotating, so the position LED is not glowing. Never try to rotate the shaft of the motor with the help of this slider manually, otherwise it will damage the gears of the motor.